Hello and welcome to another tutorial. We are continuing our discussion on methods in Java, and we reached to the point of looking at variable arguments for a method. Basically, the idea is that what if we want to define a method? So we declare the method, but at the compile time, when we write the source code, we don't know how many arguments the user of the code, when somebody calls this method, how many parameters or arguments is going to pass, right? Java provides a solution that's called variable arguments, and the way you define, obviously the easiest solution is to have an array. So instead of saying that, for example, in this example, having these corners, we define this as an array, which was the previous topic, right? But then the user is forced to basically create the array outside the method, and then after that call the method and pass the array to it, right? And now the problem with this is that this array is obviously created outside. This corner is a reference to an object, and because what happens now, the method could mutate it, right? So there is no way to make this read-only, because object references, there is no concept of const correctness in Java. And we saw that the arrays of references is still an object, right? So point array, even though point is a class, point array is still an object, and it's a built-in object. Arrays, whether primitive types or reference type arrays, are built-in objects, right? There is no class definition associated with an array type, but they are built-in objects into JVM. So you can use a construct called vararg, which means variable arguments, to pass an arbitrary number of values to a method. Now what happens here is that because then you're not forced to create an array outside and then you pass it in. You can if you want to, but then you can also directly write the components of that array, right, to this method, and then JVM behind the scenes creates an array. And because you don't have access to a reference set array, that array is more like a read-only array, right? You cannot you can mutate it inside the method, it's possible, but it's more like convenience in terms of how the array is going to be created for you, right? So you use varargs when you do not know how many of a particular type of arguments will be passed to the method. And again, the vararg part, which means we use the type and ... Remember, for the array we use the type and then square brackets, which means now this parameter is an array type, array of a particular type, right? But then for vararg, the notation is ... which means this will decay into an array, but we don't know how many elements are going to be passed to the method, or how many elements that array is going to have at compile time. Because we said that arrays at compile time, in fact, the compiler has to know the size of the array, right, the elements. But for the vararg, this happens at runtime behind the scenes, and we will look at the bytecode, right? It is a shortcut to creating an array manually. The previous method could have used varargs rather than an array, right? So the easiest thing is to declare the method as a parameter that takes an array. The other way is to create a method that takes a vararg, and we will see that this is not a valid overload. So you cannot have the same method that takes an array type and then a vararg type, because behind the scenes in the bytecode, the compiler will transform this code, the vararg, into an array definition. So this is just a syntactic sugar, which makes life easier, right? Instead of forcing the user to create the array behind the scenes, or we've seen that you can use the new operator directly to create an array in place and initialize it. But then this vararg notation simplifies that. You don't need to explicitly call the new operator. In the bytecode, the Java compiler has already written all the bytecode necessary to create an array behind the scenes and pass these elements of the vararg for the arguments basically into that array, and then continue moving forward. So obviously when you are inside the body of the method with the vararg, this acts as a regular array. So you know how many elements are passed in, because every array has a length, which is a final field, and you can directly see how many elements are inside. So varargs is a easier notation, but behind the scenes it will translate into an array, right? So you can see that inside the method, the variable, the parameter is treated like an array, because behind the scenes in the bytecode it will be transformed into an array. The method can be called either with an array or with a sequence of arguments, and that's the whole point. So this notation vararg is exactly equivalent to array, with the basically convenience that you don't need to use the new operator to create an array and then pass that array to the method. You can just directly type the elements of the array using the comma separation, and then the JVM creates the array behind the scenes for you. The code in the method body will treat the parameter as an array in either case. You will most commonly see varargs with the printing methods, for example this printf. So printf is a built-in method inside the system.out. So in the print stream class, for example, it's printf means print a formatted string. So you pass a string that has a special sequences which are called formatting sequences, and this notation came from C and then inside C++. Although in C++ this kind of string formatting is discouraged. Now they have operator overloading, so they encourage not to use this kind of formatting. But in the C, printf is a very common function that we always use, and that came to Java as well. So print s, %s means we want to put a string here. %d, we want to put a decimal, an integer here. %s, which means we want to put a string. %n or \n means we want to have a new line character. So name is a string, ID number is an integer or %d, %decimal, and then %s address is a string, etc. Right? So as you can see, the signature of printf, because we don't know at runtime when somebody calls this printf how many arguments is going to pass. We know that it's definitely going to pass a string, which has the special characters for formatting, these %s characters, but then we don't know how many formatting characters this string has. So we define it as a vararg parameters for this method. Now the limitation of the vararg is that first of all of them have to have the same type, but we know that the user can pass a string, pass an integer, etc. So what we do, in Java, when we want to mix different types, we use a type that is the super type of everything, which is object, right? Now we could, if we limit the pool or the set of types that these arguments are allowed, then we can use a parameterized type and put a lower bound on or upper bound on it. This is an advanced topic, and we will look at it when we talked about generics in Java or parameterized method, etc. But for now, if we want to mix strings with integers or anything else, we have to use the object type. But we say object dot, and then people pass the elements of this array as a regular arguments by separating them with comma. And then when the JVM looks at this, it realizes that, okay, this is the first argument because it matches the signature, which is a string, and anything after that is transformed into an array of objects, right? Remember, a primitive type will be converted to a wrapper integer type, and this always happens automatically by the compiler. So you might say, okay, object is a class, but can I pass primitives? The answer is yes, you can, just because every primitive has a class or object type associated with it, which is called a wrapper class. Or like this, so a string, decimal, integer, a string \n, and we have now 5 parameters. And the code, the same method still works fine, because all these parameters elements will put, all these 5 arguments will be put inside an array of type objects, and then inside the method we have access to the length of the array and also the elements, and it has no problem figuring it out, or with yet a different number of arguments. All right, so I hope you understand the importance of these varargs. It definitely has its own unique use cases, and again, the whole idea is that this is a syntactic sugar for a parameter of type arrays, because when you define arrays, you cannot, the JVM cannot convert a comma separated list into array. That will happen when you define a variable arguments. So let's create a new class and explore all these different options. So varargs, all right, let's have a main method here. All right, what do we want to do? We want to say public void say hi, right? And then or maybe print names and then a string name. So we're going to have one argument here, right? And then we're going to have, for example, two arguments, name1, a string name2, and then we're going to have another one that takes a string names, right? It's going to take an array, names, a string array. This is valid. So sometimes even in the JDK you see this kind of codes. We don't know if there is a method that we don't know how many elements are going to be passed when the method is called. Obviously Java allows method overloading, and the parameters are part of the signature. So this is a valid overload. We define the same name, the same signature, access modifier, return type, but with one parameter, two parameters, three parameters, four parameters, etc. Right? But then obviously as we cannot have infinite number of parameters. At some point we have to cut it. Let's say the default convention in JDK is, for example, 1, 2, 3 up to 10. After that we just convert to an array. Here I have two, one parameter, two parameter. These have explicit basically implementation or explicit code. But then the more than two, then we revert to an array, right? And then what we're going to do, let's first of all look at and let's create an object. So varargs, let's say va is new varargs. I'm calling the constructor. I didn't explicitly define any constructor, but we know that if we don't explicitly define a constructor, JVM is, the Java compiler is going to add a public default no arg constructor, which just calls the superclass constructor, in this case object, right? And again, to refresh your memory, if a class doesn't explicitly extend another class, the compiler adds the extends object, right? This will be explicitly added. So if I remove it, nothing in the bytecode is going to change. That line extends object will be there, right? Now I created an instance and I can say va.printName, and Eclipse's autocomplete tells me that there are three methods, which means with the same name, print names, which means this method is overloaded. All of them have the same return type, but then one of them takes one string, the other one takes two string, and the third one takes an array of a string, right? So print names Bob, and when the compiler sees this line of code, it binds this method to this one, because compiler knows that, okay, this takes one string, so it has to be this one. Every method has to have a unique signature. Every method has to have a unique signature, which means it has to have a name and the parameter types. And the reason for uniqueness is that at compile time, obviously the only thing that when somebody invokes, some object invokes this method, right? What does the compiler see? It sees that the name of the variable, which the compiler knows that it is associated with the type class, and dot operator, the method name and the parameters, right? So in this case, the compiler has no other information, right? It doesn't know what the return type is. That's why the return type is not part of the signature of the method, because when somebody calls a method, first of all, the compiler checks that if this variable that has a particular type actually has a method with this name and this type of parameter. If it doesn't, obviously you get a compilation error, right? And the IDs help, because when you say dot va dot, it shows the autocomplete shows all the possible methods, which is very nice feature, so you don't end up with those kind of methods. So use auto complete or auto suggestion. Some people call it IntelliSense, for example, something like that. Basically it's just an intelligent thing built into the compiler, into the IDE, right? And then when you type a few name, it highlights which methods are available inside the type that this variable is from, right? So that's very nice. Print names again, and then we say Bob and then Jack. So now when the compiler sees this, the only information that compiler has is that this method is inside this type, this class, and it takes two arguments. So because of the uniqueness of the signature, which means the name and the parameter type, the compiler realizes that this method, this call to the print name with its parameters, is this one, right? Again, that's why the access modifiers and return type and whether a method is abstract or not, that's not part of the signature, because when somebody calls the method with the given parameters, the only information that the compiler has is what's the name of the parameter, what's the name of the method, and what are the types of the parameter. And obviously the order matters, but here in this case the two parameters have the same type. Okay, so if one of them was a string, the other one was, for example, was int, then that's different from the first one being int, the second one being a string, for example, right? So the order of the parameters and the type of parameters, the name of the parameters don't matter because they will be erased in the bytecode. There is no trace of what the actual name of the parameters were in the source code. All right, so and obviously we can say va print names a string Bob, and then Jack, and then Jane, right? So if we do this, we get a compilation error because this comma separated list of strings, right? Bob, comma, Jack, it doesn't bind to an array. So basically a comma separated list of strings like this, it doesn't bind to a, it doesn't automatically bind, does not automatically bind to a string array. And that's the whole point of converting. So what's the solution here? Let me copy this and then paste it again, and I'm going to comment this. The solution is to either create an array, a string array beforehand, like a string array SA equals, and then we immediately initialize it with these elements. And we saw that when we immediately initialize an array, as soon as we declare it, we don't need to use the new operator, and we pass SA here. Now this obviously is array, so it binds to this method. And know that even if I have two elements, it's not going to bind to this one. So actually let's do a sysout to check the which method is actually being called. Because obviously one ambiguity is always that, what if I pass an array that has one element or two elements? Does it bind to this one that has one element, or it always binds to a method that has the parameter is an array? And the answer is that the compiler always tries to find the exact match. So compiler always tries to find the exact match. If the compiler cannot find the exact match, then it tries to look for alternatives. But if the exact match in terms of the parameter types, right, exact match in terms of parameter types is found, that's the one that compiler always chooses. So even if I pass a string array, so my parameter, this method has one parameter, which is a string array, but a string array has two elements, two strings. But this call to this method is going to always bind to this method that takes one parameter of type string array. And again, this is where the statically typed feature of Java comes into play, right? So for the second one, we can do the same thing, saying that this method is called, and then for the third one, we're going to also have this. All right. If I run this, let's see what happens. Now the first call, obviously the parameter is of type a string, and it binds to the method, the overloaded version that takes a string. The second one is the one that takes two strings, not in an array but separately, two parameters, each one is type a string, and it binds to the one that actually takes two strings. The third one is an array that has two strings, but it doesn't bind to the method that has two strings. It just binds to the method that takes one parameter of type a string array. Now we're going to switch to okay, so one last thing here is that instead of doing this, you see a lot of times you see that we define the array in place. We say that a new string, right, and then directly initialize it. This also works, and we saw that in this notation you shouldn't specify the number of elements. because this is just says that create a temporary reference to this array. It has an initializer list, so the compiler has to infer the number of elements from the initializer, so you should never put a number of elements here. All right, this is called in-place creation, in-place creation and initialization of an array. And again, we will say this is still one argument, which means this method is also going to bind with the method overloaded version that takes one parameter of type string. And as you can see, it binds, right? Now, what is vararg? So vararg, or variable arguments, variable argument is that we want to keep, the user to be able to put any number of strings as a comma separated syntax, because it's a very nice syntax instead of writing new string array and initializing it. So we just want people to write the number of elements, the elements as a comma separated thing. So we use vararg, and the syntax is going to be exactly the same, but instead of saying the string array, we say a string dot dot dot. And you see that the compiler doesn't allow me to have two overloaded methods with the same name, but one takes one parameter of type string array, the other one takes a vararg string. Why? Because behind the scenes, vararg will be converted to a string array, right? To array in a bytecode, which means the actual bytecode of this method exactly has the same signature of this one, right? So first of all, if I comment this out, and then this works because now this method has a unique signature. The name is print names and the parameter type is a string array. So a string dot 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 will be transformed into a string array, and we can look at the bytecode to check on that. So if I open the bytecode for this class in the class file viewer, let's see what happens. So let's zoom in a little bit and open this up. And so we have a constructor, public no-arg constructor, that's the default, and all it does, it calls the superclass constructor to initialize it, and we didn't explicitly write this down. The compiler adds that to the bytecode. And we have one method, print name, takes a Java lang string and returns void. The other one takes a Java lang string and returns void. That's the second one. The third one takes a Java lang string dot dot dot. All right. Now let me comment this vararg out and bring back the previous one. This one now it takes a Java lang string array. So it looks like there is a little difference in terms of basically in this notation here, it says that Java lang string array with square brackets. For the vararg, it says that Java lang string dot dot dot. So it looks like the signature is different, but let's look at the method descriptor to see what happens. So for the method descriptor, arrays are a square bracket and then the type inside the array, which is the reference type Java lang string semicolon. So let's look at the other one for the vararg. All right, this one. Now, as you can see, now it says Java lang string dot dot dot, but if you look at the method descriptor, it's exactly the same as before. And again, the method descriptor is also should be unique. So also in the bytecode here, we see dot dot dot. The signature is still array, a square bracket, Java lang string semicolon, and the return type is void, right? So it's a method descriptor that tells us that the vararg version and the array version, they have exactly the same signature. All right, so just be careful that vararg and array doesn't you cannot overload based on those two, because to the compiler they're the same. So why is it that here we have a string dot dot dot? That's because if the vararg is going to be treated basically especially here, if you see varargs, right? Let's look at this one. So what happens in this string dot dot dot? So this is for the syntax that we have. So let me just comment this out. Just look at the body. What's the implementation of this vararg method? And right now we just return, so nothing happens. So where does basically we know, where do we know, from where do we know that this string dot 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 gets transformed into array? Here it says that these are the local variables of this method, and we know that the parameters of a method are local variables of the method that are pushed to the stack, right? So there are two local variables for this method because it's a non-static. The first one is the this pointer, right? It's at index 0, and then the names, which is at index 1, and the type is a string array. So also here it says a string dot dot dot. We saw that in the method descriptor it's still a string array, and in the bytecode it also identifies the type of the string array, right? So again, vararg is a syntactic sugar, and the whole point of the vararg is to make the syntax when you write the source code more convenient, because instead of creating in place arrays, we can now say that print names Bob, Jack, Jane, right? And this works fine, and behind the scenes what happens is this will transform into an array behind the scenes. And let me bring back this comment here, this print. So if I run this, as you can see, this one that we pass one parameter, we create an array outside, we pass it, it binds to the vararg, because for the JVM this vararg is just a syntactic sugar of arrays. The Inplace array also binds to the vararg, okay? And finally a comma separated list of the same types bind to varargs, right? Now if I put, for example, 1 here, this is going to give me a compilation error. That's just because basically we know that an array, by definition, all the types have to be exactly the same and no implicit conversion allowed. And in Java, obviously, an integer doesn't implicitly convert to a string. All right, so this is not allowed. But if I say if I pass an object, let's say integer value of 1, this also doesn't work, although one would expect that this might call the Twostring method, but that's not going to happen because all these elements are going to be converted into array of type string, and obviously an integer type is not compatible with a string, right? So be careful about that. This kind of implicit conversions don't happen. If I say 1 plus empty string, this will execute it first, and this will convert it to a 1 with double quotes, which means now it's a string, and this works fine. All right. Now let's quickly look at the bytecode again, and then we end this lecture there. So let's look at the third method here, which takes a string args. And again, the type is a string array. So dot 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 is just array. Arrays bind to the string dot dot dot, and also a list of comma separated strings also binds to the varargs. And we're invoking the virtual Java lang string. So let's use the name somewhere here. So int x is names dot length, right? Remember, this vararg is treated as like array, so it has the final feed length that tells us how many elements are passed at runtime, because at compile time the signature of the method doesn't tell you how many elements are passed, but at runtime we know that how many elements have been passed when the method is called, and then now we can use that information using the final feed length inside the array, right? So if I save this, Eclipse compiles this, and let's save this. This is going to be compiled again, and then let's look at this, and now you see we have a load 1. Okay, remember this pointer is at index 0, this because this is a non-static method. Names is at index 1, and the type is a string array. So it's an object. A string array is an object. So we say load at index 1 a reference, an object, a reference, which is names, which is an array, and then get the array length, right? And then which is a field, and then I store it index 2. What is at index 2? The variable x, type is int, right? So as you can see, this names is basically an array. So the dot 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 notation converts the either an array or a list of comma separated types variables into an array. So that's the syntactic sugar. Now let's see what happens actually in this line. So let me just put something like Jane here. So if this a string dot 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 is treated as an array, so the conversion of a list to a comma separated value list to an array must happen at some point, and that happens when you actually call this method. So let's go down in the main method. In the main method now we're just creating this new varargs invoke. We have to call the constructor when you use the new operator. We store it. Now let's see what happens here. Actually up to 28 right here. Now immediately after creating the object, the next line is to call this print name method, and the call happens at line 28. So a lot of stuff happens in between of creating the object and calling this method, and all these line of bytecodes are for converting this comma separated list to an array, so that this string, the signature of the method is correct, right? And these happen behind the scenes. So a-load1, we're saying that get a reference to the object iconst3. Iconst3 means we have 3 elements, and then a new array a string. So it says create a array of type a string. So let me comment this, put a comment here. And so iconst3, that's the or maybe let's go multi-line. Iconst3 and then a new array. Alright, so we're creating a new array of type Java lang string, and then duplicate it iconst0, and then load a string const bob, and then a store. Now what is this? We've seen this code before, and we saw that when you try to create an array, when you say a string array x equals basically when you directly initialize with something like this, basically the compiler, when it sees this code and it knows that this binds to a array using the vararg notation, it actually creates this line of code. And we know that the implementation of this direct initialization is unfolding, which means the compiler creates this line of code. Let me just write it down. It says a string array x equals new a string array with element 3. That's where this iconst3 comes from. And then x at index 0 is bob, and then x at index 1 is jack, and then x at index 2 is jane, right? So iconst3 a new array is basically this line of code. Because in order to evaluate this line of code, first you have to load this literal, which is 3, and we saw that 0 to 5 plus minus 1, the bytecode is iconst, integer constant 3. And then we have a new operator. We say a new array, create a new array of type a, which means it's a reference type, object type, a string. And then we move on to execute this line of code, which means we have to first load this 0. That's why we're saying that iconst 0, load the index 0, and then load this string literal, right? And these are going to be loaded from the string constant pool, because these are string literals. And then a store, which means at the last index of the basically inside the array, the last index is 0, obviously. Then so basically a store means a store in a array of type object. A string is object of. A store means store an object into an array of type object, right? A store. The prefix a means object type, reference type. That's why we are saving this object type, reference type, into this array, this variable at index 0, and this variable is a array or reference array type. And then the same happens to the next line of code. We have to say iconst1, which means if we load this, explicitly load this integer 1, and then load the constant string jack, and then save it. into the array. And finally, the third one is load the index 2, and then load the element, which is a constant string, and then basically store it in the array. So this whole thing, before calling the method, the preparation happens by the JVM, and the compiler has already written the bytecode. In the bytecode has already written extra code to convert this comma separated list into an array, and the array is going to pass to this, right? So the signature of the method is actually a string array, but because of the syntactic sugar and the convenience of the notation, the compiler has to do extra work to convert this list into an array first, and then the method is called and the array is passed to method. So in work virtual, we are calling a method. What is that method? There is a method print names that takes a string array, not a string ... and returns void. So all this preparation happens by the compiler before this method is called, when the compiler hits this line of code. So I hope you have a very clear understanding of what happens behind the scenes for the varargs. It's an important concept. It has its own use cases. So please stay tuned, and I'll see you next time.